From my experience in microbiological research, I have become aware of what I believe to be a relatively unknown, unexplored niche that holds a potential plethora of undiscovered antibacterial, antifungal substances. Where? What is this niche? It exists in the deep forest, swamps, marshes, soils, even farm ponds and backyards of northern Wisconsin and Michigan's Upper Peninsula. Indeed, almost everywhere, for those who would grasp this concept. It is being produced naturally by plants, animals, and microbes. How can it be that such important substances have not yet been discovered? Well, let me start with the least to the most promising, as I see it. Animals, most of which exist on a macro level with us, are the most unlikely source. Why? Well, they evolve at a pace most similar to us. They're the most consistent, relatively, in their genetic status. What I mean is, what they were 100 years ago remains relatively unchanged today. Still, they must not be ignored as a potential source for antimicrobial substances. Of the larger animals, any contact with environmental bacteria on a regular basis must be recognized as a potential source and investigated when identified. For example, deer hooves contact soil constantly. Is there an antibacterial, antifungal agent that they might produce to naturally protect them from infections there? Has anyone ever looked? Amphibians lay their eggs in bacterial, fungal-laden, stagnant waters. Are there antibacterial, antifungal substances they produce to protect their developing eggs? How about wood tick saliva? What about fish epidermal slime? Insects, they've already proven to produce powerful antimicrobial alkaloids and other small molecules of interest, one of which is the subject of my discovery detailed in my formal paper available for study on my website. More remain to be discovered in these areas. Add to this the potential undiscovered forms of primitive animals such as freshwater sponges, bryozoans, hydrozoans in remote areas. Yep, even animals have potential. Plants, well, they have served as a source for a wide variety of drugs and dietary supplements. According to clinical microbiological reviews, as of 1999, 25 to 50% of pharmaceuticals are derived from plants, yet none were used as microbials, antimicrobials at that time. A new look at plants is needed for this, especially again in the relatively wild, microbiologically uncharted places such as northern Wisconsin and Michigan's Upper Peninsula. This leads us to the final and what I believe to be the most promising source for new, novel, antibacterial, antifungal substances. They are bacteria, protists, fungi. Why? Well, these microbes have already shown to be a source for many of our most widely used antibiotics. Penicillins, cephalosporins from fungi, tetracyclines, macrolides, aminoglycosides from bacteria, and the list goes on and on. The evolutionary potential for these microbes to evolve to produce novel antibacterial substances in the relatively isolated gene pool pockets of northern Wisconsin and Michigan's Upper Peninsula represents an untapped niche for antimicrobial substances. I mean, let's think of this. Under optimal conditions, bacteria can reproduce every 20 minutes. They have the ability to incorporate random genetic information from their local environment, and they can accomplish primitive sexual exchange of DNA via conjugation. powerful with respect to their ability to evolve quickly. Unicellular fungi and protists possess relatively similar evolutionary potential compared to, again, macro animals. Combined, these factors present a powerful parameter that even known microbial species as defined in the literature could be very different in their relatively isolated gene pools, such as I've identified. And this is not to mention potential undiscovered species. I propose to function as a micro-scavenger, searching these relatively isolated gene pools for novel antibacterial, antifungal substances, and present them to entities that can develop them then into needed antibiotics. Thank you.